They're glitzy, high-tech devices that provide us more information, connectivity, and convenience than ever. They've transformed the way we do so many things, one is tempted to label them as magical. But open up this digital wizardry and you'll instead see metal and plastic, the results of years of hard research and brilliant engineering. You'll also see future electronic garbage, harmful to human health and the environment. E-waste is the fastest growing segment of hazardous waste worldwide. As much as 30 pounds of metal goes into a desktop computer. Engineers weave together copper, tin, lead, even an ounce or so of gold and other metals, along with plastics and chemical compounds. Materials are mined from the earth, refined, crafted into components, and assembled. Each step balances economy and environment, worth and waste. In the end, maybe you have a computer, a cell phone, or a high-definition television. While these devices are useful, they are made from materials that can't simply be thrown away. Metals and plastics present hazards if recycled improperly, something that is happening all too often as waste is often shipped to Africa, India, and China. Consumers worldwide snap them up, but their lives are short. Even when obsolete electronics are reused, eventually they become e-waste. And all too soon they end up here, or worse, here, or even worse, here. Europeans discard 6 million tons of e-waste every year. Up to 5 metric tons end up in U.S. landfills. China discards 14 million computers a year. Worldwide, 20 to 50 metric tons of e-waste are generated each year, and the amount is growing. As more developing countries use electronics, the problem will grow, especially in countries where environmental regulations are weak or non-existent. The European Union is moving to force manufacturers to take back products that have reached the end of their useful life through a program called IEEEtv, and to remove certain hazardous substances from electronics, a program called ROS. Japan has also enacted similar laws. Backers hope such legislation will force manufacturers to consider end-of-life issues at the design phase. But green engineering design, also called eco-design, is a complex idea that usually involves many companies working together on just one product.
If you are in charge for, let's say, for the waste management of your products, you may start thinking in another way on designing it at the very beginning.
There's not so much deep thought involved here, but an awful lot of very careful looking at what you're doing and trying to do it better or slightly differently.
This thinking is more than just building a device from non-hazardous components. It's about analyzing the device's environmental impact over its entire life cycle.
If you make a life cycle assessment, you could realize which are the most important part of the life cycle. Is it during when you are producing the raw material? Is it when you are producing your product? Or is it when you are using the product? Or is it the end-of-life treatment, which is the important thing? And then you could go to the product development department and say to them, now we realize that the big environmental impact is from this or that, and then please do work on that.
This is a lesson the European Union learned only after they banned lead in electronics. Lead is an important component of solder, the very thing that has been used to connect components since the earliest electronic devices.
Lead tin, that combination of those two elements, it's actually something that's pretty special. It's a metal, it conducts electricity, it conducts heat. It's a pretty ideal material in terms of being able to melt at a low temperature, wet it to other materials, and then cool it down and have it behave in a circuit board.
A silver-copper-tin combination was introduced as a lead-free solder to comply with ROS, but a full analysis was done only well into the process. It turns out mining silver is harder on the environment than mining lead.
I think the microelectronics community was caught a little bit flat-footed when this ban was coming into effect. They hadn't really considered what the different alternatives were long enough ahead of time and done the life cycle analysis to really see what was going to happen.
In addition, the new solder joints were weaker, making things like cell phones easier to break.
So it can only take maybe half as many drops as one originally was able to do with this lead tin solder.
The EU granted exemptions for things like aircraft, military, medical devices, and servers.
With a very complex product structure in our high-end servers, we need various stages of reflow. So there is a server exemption at the moment, and we have a hard time basically to implement lead-free soldering throughout our product groups.
Not everyone approves of the RoHS exemptions.
Clearly Greenpeace wants companies to go further than the RoHS directive. It is a minimum and there are far too many exemptions, and the exemptions are growing by the day.
Researchers are pleading for more study.
We want to make sure that if you buy a cell phone, that it's going to last at least as long as the cell phone that you have now. It's not an environmental bargain if you have to buy twice as many devices, twice as many cell phones, twice as many Sony PlayStations, because the first one breaks because this new material isn't quite as good.
This may not be important for all electronics. For example, consumers move on to the newest cell phones and cameras so quickly, the old ones don't have to last very long. However, the lead issue has European Union officials thinking more critically about the impact of electronics. A new directive, EUP, or energy-using products, will require a complete life cycle analysis of products.
That means what is the environmental impact coming from the use of resources, the production of these products, the use phase, and what's about recycling.
The use phase is emerging as a critical point that will need further examination and action.
Everyone I looked into, they have their main environmental impact during use phase because of energy consumption and other things like that.
The use phase is where people are using the devices and the devices are using energy. The impact of one device is minimal, but when you look at all the devices that are being made and will be made, the projected energy use is significant.
There is a huge explosion of energy consumption all over the world, and there is an estimation that there will be somehow 60% energy increase.
That energy will have to come from either conventional or alternative energy sources. There are conflicting estimates of how much electricity clean energy may supply. Environmental groups say it could supply up to 50% if governments crack down on using fossil fuels. But the International Energy Agency says the figure is more likely about 14%. The technology for green energy is immature. For example, wind energy has been around for years, but many problems remain, such as you have to go where the wind is, and you have to build efficient transmission lines to bring it to population centers. In countries like the United States and China, for example, this is a major challenge.
I mean, if you go to the Dakota Plains, there you have the wind resource, but you don't have the demand. But we have, for the time being, not the transport infrastructure to ship huge amounts of electricity, which we would generate in these wind-rich regions, to the centers of consumption, which would be California or the East Coast.
That means energy-efficient electronics are vital.
You actually don't look at the part of the system, you look at the entire system. You don't look only at energy supply, not only at the windmills and renewable energy supplies, you also look actually at the demand.
Which means coming up with devices that are more energy efficient. But will that be something the consumer wants? Opinions are mixed.
Almost all inquiries are coming from commercial customers. Only very few are coming from the consumers. We did some research into that. One of the major reasons is that the consumer just doesn't understand.
We predict there will be a time when product manufacturers are competing each other on the market with the environmental compatibility of those products.
Others see that even without consumer support, it can benefit companies.
Eco-design is a way to earn money. Because if you make eco-design in a proper way, you usually save a lot of material or energy, and that is savings money.
But there's more to it for companies than just money.
If you avoid toxic materials, you also are avoiding the potential for legal liability in the future. And one increasingly, I think, with young people that have grown up thinking that the environment is crucial to them, your employees want to work with companies that are environmentally responsible.
But toxic materials are a part of everyday electronics. Designing them out is much more than swapping a few parts. It's a challenge that involves rethinking the basic building blocks of many devices we rely on every day. And such a challenge will require some very innovative engineering.